All right, we are live. Okay, so this is 6.5, 6.6. Jaden's gonna go first, actually. You guys still gotta go? You gonna hit the head?
Oh, already went.
Oh, look at that. Okay, go for it. Good, we got that on video too.
Good job.
For the record, Sierra Ringdale is going to the washroom at 9:11 on this April 28th. Okay. 29th? Whoa.
Wow,
Okay. Look at that. 30 seconds into the video, we've gotten nowhere. Excellent. Okay, so for this 6.5, 6.6, it's just a continuation basically of 6.4.
Well, didn't you say yesterday that when we start like actually finding out like the price of things?
Right, we're going to look at like making maximum or minimum amounts of money or losing minimum amounts of money based on costs. This is where linear programming is really cool. At the very basic level, what you guys are doing, you're finding out how to make a little bit of money. You start doing this in business or running like a business like a farm, agriculture, it really can help, become more efficient. And it gets way more complicated than what you learn now when you're 16, 15 years old, when you start, applying business models and stuff like that to it. This is just meant to give you an idea of how the system works. So here's the steps you follow. You always define your X and Y variables. You create your system, so those are the, the parameters, your constraints. Determine the objective function, you graph it. Find the vertices where they connect, point at the intersection. Evaluate, and then compare and get the result that you want. Okay? Then it says here you can verify your solution. The check is always up to you. All right? I'm not going to make you do it on a test, but it's a nice way to double check. Okay, so a toy company manufactures two types of toy vehicles, racing cars and sport utility vehicles. So right there, we can set up our X and Y.
For toys?
Yeah, two types of toy vehicles.
Yes, the children do care very much about whether they have a racing car or a sport utility vehicle.
Yeah, man. You kidding? Didn't you guys grow up with like a bunch of different like little dinky cars? And they mattered. Uh-huh.
That was my whole life.
See?
Yeah, but they're all racing cars.
This guy gets it. Oh, SUVs.
You rolled up with SUVs.
There's a huge difference between like a Audi A4 and a Cadillac Escalade, right?
Yeah.
Right? Or an F1 racing car. So, all right. So because the supply of materials is limited, no more than 40 racing cars and 60 sport utility cars can be made each day. So, racing cars, X has to be less than or equal to 40. And sport utility vehicles can be no more, so less than or equal to 60. Terry, you're going to have to wait till I'm done this, okay? Now, the company can make 70 or more vehicles in total each day. So that means 70 or more. So if you add up all your race cars and all your SUVs, that's going to be greater than or equal to. We'll make more. Sorry, that's just going to be greater than 70. Okay, each day. It costs $8 to make a racing car and $12 to make a sports utility vehicle. There are many possible combinations of cars and vehicles that can be made. The company wants to know what combination will result in minimum and maximum costs.
In my textbook, it says to make 70 or more vehicles.
70, oh, it does say 70 or more, so I was right the first time. There we go. I just saw the 70, more than 70. I'm dyslexic. Okay, so max or min cost. We're dealing with costs here. So our objective function, I'm going to put down here. We use C for cost. It's going to be $8 per racing vehicle plus $12 per SUV. Right? Okay, so now all we got to do is graph this stuff. Because we're dealing with costs and everything like that, we're only going to be dealing with positive values. So your graph is actually going to look, I'll draw it. Now my scales are going up by like 70, 60, 40, so I'm going to go by 10. so now we graph these, okay? So race cars, x is equal to or less than 40. So this guy here, it's going to be that nice straight line there. Y is equal to or less than 60. All right, so we got a point of intersection. And then x plus y is going to be greater than or equal to 70. Okay, so to graph that, you find your two x and y intercepts. So x is 0, y equals, and y is 0, x is equal to.
So you just cross 70 to 70?
Yeah.
Yeah,
And then you just connect them. So, now, my zone of influence and what I'm looking for here, y would be, or sorry, x is less than 40, so I would shape this way. Right?
Yeah.
Y is less than 60, so I'm going to shape this way. Then I got to double check this one, greater than 70.
So you shade away from the 0.
Right. Like that. So I'm in here. Okay, so these are now my areas. So this one here is at 40 and 60. If this is 40 here, okay, I didn't draw my graph perfectly, but if I put 40 into here, what is y going to end up equaling? If x is 40, what does y have to be to give me 70?
At least 30.
Right. And if this one, if my y value is 60, what does x have to be to give me 70? 10, very good sense. Right? They have to add up to 70, if that makes sense.
Yeah.
Okay. I'm kind of going quick here because I don't want the video to go on forever. So if it doesn't make sense, let me know.
Oh, do you care if we like draw where restraints are or anything, like the symbol and the E and then the whole number against your
No, that part I don't care about. Because you're dealing with
whole number.
the whole numbers here, right? You're dealing with real values. So for this part, I'm not too worried. So, okay, so those are my three possible outcomes. So now I take each one of those and I plug it into my objective function here. And I see which one gives me my maximum and minimum cost. So I'll do each one. So times 10 plus. Then my next one, 8 times 40. And then you figure all those out. $100, 720. Oh. Spare 40. And then 320. $680. So this is my min. This is my max. Okay? One more? Let's do one more.
So do you usually just plug in your points of intersection then?
Yeah, it's just your points of intersection.
Yeah.
Okay? Example.
Everything else won't be maximized or anything.
Right. Yeah. Well, they could be, but they don't fit within the constraints of the problem.
Yeah.
Right? they only had so many resources to make so many cars. Okay, LNG construction is competing for a contract to build a fence. The fence will be no longer than 50 yards, and will consist of narrow boards that are 6 inches wide, and wide boards that are 8 inches wide. There must be fewer than 100 wide boards and no more than 80 narrow boards. Okay. All right. I think this is the one where I got to convert yards to. Okay, so doesn't matter. I'm going to make my X my narrow boards and Y my wide boards. Okay, so that's what I'm trying to figure out. Narrow boards, wide boards, and then I know the cost of the boards. Shake out like this. I want to find the minimum cost and the maximum cost of lumber. This question was clearly written in the good old days before lumber became crazy expensive. I don't know, maybe you guys have heard about that?
Yeah.
It's ridiculous. Who pays $9 for a 2x4? All right. So, the one thing I hate about this question that you just got to work with me here is the lengths of the boards are given in inches, whereas the length for the fence is in yards. So you need to convert yards into inches. Now, workplace math, Ava Gasper. How many inches are there in a yard?
No, 36.
36 inches in a yard. Very good. 3 feet to a yard.
Yeah.
12 inches to a foot. Yeah. So we just know that 50 yards times 36. Oh man, I haven't done mental math in 6 months. My brain is brutal. 1,800. Right. Very good, Eva. I just totally put you on the spot and you did it. What's that?
I almost said 3.
It's too bad. I totally would have laughed at you. All right, so we know. All right, so there must be no fewer than 100 boards and no fewer than 80 wide boards. So wide boards have to be greater. Oh, so yeah. We're all seeing that I'm trying to erase this, right? Try to scan. So, my wide boards, no fewer, have to be greater than or equal to 100. There must be no more than 80 narrow board, so X has to be less than or equal to 80. All right, and we know. Okay. All right, this is in inches here now, right? So we know that 6 times my narrow boards plus 8 times the number of wide boards has to be no longer than 80 feet. So that has to be less than or equal to 1,800. Does that make sense? Because that's my length.
Yeah.
Okay, so those are my constraints. Now my objective function to find the max and min cost. I'll do C again for cost. Cost would be 356 in narrow board plus 436 per wide board. Right there, bud. You're welcome. All right, so is it saying Walla Walla Bing Bang? Now, again, now what? Okay, you're complaining about something, I can
She
tell.
asked me for answered questions, but not the teacher of the class.
Good. Don't ever ask me a thing. That's the takeaway from today's lesson. Never.
Make
I'll be-
sure Mr. Weber doesn't do his job.
Yes.
He's still gonna get paid. So it doesn't matter.
Exactly. Just let me finish this. We're killing a bunch of dead time right now. No one's learning anything. This video is getting boring and boring
It's gonna be like one of the 35-minute long ones.
More boring. I'll help you in a second. If you want, just jump to the next question, okay?
Okay.
All right, so again, these are going up by relatively really big numbers. So my scale here has to get somewhat interesting. I'm going to go up by
150.
let's go up by increments of 40. And again, I'll have no negative values, so I just have to draw the first quadrant. Like so. Okay? First one, X is at 80. Solid line 2. Boom. Y is at 100. Boom. I'll do my, I should do my shading. X has to be less than 80. Y has to be greater. So already by now you can kind of tell where your zones are going to be, right?
Yeah.
Now for this one, I'll do a little bit of the work down here. If X equals 0, I got 8Y equals 1800. I can't do math anymore. Y equals 225. Something like that. And then I have Y equals 0. I have 6X equals
300.
very good. Oh, which is going to put me like here. Brody Ringdahl is calling me.
After on video to see what shenanigans ensue.
Yeah, I'm just recording and I'll be right there. Yeah. Okay, so, and then I would just, right there, okay? So, but then technically these two here would also be my objective. I would use 2 for my vertices. So for this one here, I know it's at 180, or 80 and 100. This one is at 100 and 0, or 0 and 100. This one's at 0 and 225. I hope everyone can read that. And then this last one here, I'm at 160 and 80. Okay? Then you would just plug these values in and see what you get for your max and min. That part's pretty straightforward. I don't feel like I need to show that again, okay?
Yeah.
All right. Cool, cool. So for you to work on,
Yeah, what questions now?
go to page 334.
Yep.
And do 1 to 3. And then when you finish those up, you'll just go to page 343 and do like 5 to 14. Okay? That's kind of a 2-part assignment.
5 to what?
13.